We continue the chapter Laws of Motion, and we are discussing the numerical problem of this chapter. Let us see question number 12. Question number 12. A bob of mass zero point 0.1 kg. A bob of mass zero point 0.1 kg hung from the ceiling of a room by a string 2 meter long. There is a bob of mass zero point 0.1 kg hang from the ceiling of a room. This is the mean position of the bob. And mass of the bob is given 0.1 kg. Mass of the bob is 0.1 kg hung from the ceiling of a room by a string 2 meter long. The length of the string is 2 meters. Is set into oscillation. The speed of the bob at its mean position. Speed of the bob at mean position is given 1 meter per second. The speed of the bob at the mean position is 1 meter per second. What is the trajectory of the bob if the string is cut when the bob is at one of its extreme position? What is the trajectory of the bob? What is the trajectory? Trajectory means path. What is the trajectory of the bob? What is the trajectory of the bob if the string is cut? If the string is cut, if the string is cut when the bob is at one of its extreme position, where the bob is one of its extreme position, when the bob is one of its extreme position. And the second part, when the bob is at its mean position, at its mean position. So this position is called mean position. And these are the one of the extreme position. One of the extreme. This is the extreme position, and this is also the extreme position, and this is called mean position. And mass of the bob is given 0.1 kg. If the string is cut when the bob is one of its extreme position, bob is one of its extreme position. So at extreme position, the velocity is momentary. The velocity is 0. At extreme position, the velocity is 0 momentarily. Momentarily, the velocity is 0 at the mean position. So the answer is the first part. Since the velocity of the bob is 0 at extreme position, and the bob is momentarily at rest at this position. At extreme position, the velocity becomes zero, and the velocity zero means momentarily the bob is at rest. So at this position, when the string is cut, then the bob comes to comes in vertically downward direction. The bob will fall vertically in downward direction. So if the string is cut, the bob will fall vertically downward direction. So if the string is cut in this position, the bob will fall vertically downward. The bob will fall vertically downward. So this is the answer of the first part. The question was when the bob is at one of its extreme position. It has two extreme positions. So when the bob is at one of its extreme position and the string is cut down, then what is the trajectory of the bob? So at this position, since the velocity is zero, it means the bob is momentarily at rest, and when the string is cut, it will fall down in vertically downward direction. And the second part, if the string is cut when the bob is at mean position. So when the bob is at mean position, the direction of the velocity is in horizontal direction. The velocity is in horizontal direction. And velocity is always tangential. Its direction is tangential. So when the string is cut at the mean position and it has velocity in horizontal direction and tangential, so the bob will follow the parabolic path and it will fall down. It will follow the parabolic path. So at the mean position, the bob has a horizontal velocity. At the mean position, at the mean position, the bob has horizontal velocity. At the mean position, the bob has horizontal velocity, and if the string is cut, it will fall along parabolic path. If the string is cut, it will follow the parabolic path. So at the mean position, when the string is cut, it will follow the parabolic path under the effect of gravity. Under the effect of gravity. So at mean position, the bob has horizontal velocity, and if the string is cut, it follows a parabolic path because the velocity is tangential always. So it follows a parabolic path. The next question, question number 5.13. A man of mass 70 kg. A man of mass 70 kg stands on a weighing scale in a lift. The mass of the man is 70 kg. And the man stands on a weighing scale in a lift which is moving upward with a uniform speed of 10 meter per second. Lift is moving upward with a speed of 10 meter per second. Lift is moving upward with a speed of 10 meter per second, and the man is standing on the lift on a weighing machine. And the second part, the first part, the lift is moving upward. The first part, lift is moving upward with a lift is moving upward with a uniform speed of 10 meter per second. With a uniform speed of 10 meter per second. So in this case, we have to find the reading on the scale in this case. The reading of the scale in this case means what is the force acting on the man. What is the force? The value of the force acting on the man. So in this case, when the lift is moving with a uniform speed of 10 meter per second, then the force acting on the man R equals to M into G. Because the lift is moving with a uniform speed, means acceleration is 0. So only the weight is the reading on the weighing scale. So the mass is 70 and the value of G is 9.8, and 70 into 9.8, we get 686 meters. So the reading of the scale is 686 Newton when the lift is moving with uniform speed. The second part of the question is, when the lift is moving downward with a uniform acceleration, when the lift is moving downward, when the lift is moving downward, when the lift is moving downward with a uniform acceleration of 5 meter per second, with a uniform acceleration with a uniform acceleration of 5 meter per second square. So here we have given the acceleration also. The lift is moving downward with a uniform acceleration, and already we have derived the formula. We have derived the formula. The force acting when the lift is moving upward and when the lift is moving downward. So in this case, the formula was R equals to mg minus A. Mg minus Ma. Mg is the weight and Ma is the force due to the acceleration acts. So the mass is 70, the value of G 9.8, and the value of acceleration is 5. So 70 into 3.8, and that is 336 Newton. So this is the reading of the scale, 336 Newton, 4.8, 9.8 minus 5, 9.8 minus 5, this is 4.8. Now the third part is lift is moving upward with a uniform acceleration of 5 meter per second square. C part. When the lift is moving upward, when the lift is moving upward with an acceleration five meter per second square. So in this case the formula is, already we have derived the formula m into g plus a, 70 into 9.8 plus 5, so 70 into 14.5, 70 into 14.5, and that is 1036 Newton. 1036 Newton. And the last part, part D, when the lift freely falls down under gravity, when the lift freely falls down, when the lift freely falls down under gravity, this was the last case when the string of the lift breaks down. So the lift comes in the contact of gravity, and the reading on laying machine, so the formula was mg minus, at the place of g it comes g, because body is under the contact of gravity. So the value of r will be 0 in this case. The next question, question number 5.14. Figure shows the position time graph of a particle. Figure shows the position time graph of a particle. Position x in meter and time t in second. Four meter and time is 3 seconds. This is 3, position is 3 meter, time at this point, at point A. At point A, the position is 3 meter and time is 4 seconds. So figure shows the position time graph of a particle of mass 4 kg. The mass of the particle is given 4 kg, and this is the position type graph. So what is the force on the particle? What is the force on the particle? The first part of the question is, what is the force on the particle? What is the force on the particle? For t is less than 0, t is greater than 0, for time t is less than 0, time t is greater than 4, and third, time lies between 0 to 4. What is the force acting on the particle? When time t is less than 0, time t is greater than 4 seconds, and time lies between 0 to 4 seconds. So, for first part, we have to find the force acting on the particle at time t less than 0. So at time t less than 0, the particle is at rest. At time t is less than 0, the particle is at rest because the particle has not been started moving. T is less than 0, the particle is at rest. So no any force acts on the particle. No any force acts on the particle. A part, at time t equals to 0, the body has not been started, means body is at rest. At time t equals to 0, the body is started. So before time t is 0, means t is less than 0, the particle is at rest. And if the particle is at rest, it means there is no any force acts on the particle. Part B, when time t is greater than 4. Time t is greater than 4. This is the graph when the time t is greater than 4. So for time t is greater than 4, again the particle is at rest because its position doesn't get changes. So for time t is greater than 4, the particle is at rest and no any force acting on the particle, and no any force acting on the particle. So at time t is less than 0, there is no any force acts, and for time t is greater than 4, the force acting on the particle is 0. Now for time 0 to 4 seconds, there is a uniform motion. The third part, for 0 is less than t is less than 4. The position of the particle changes continuously. For time between 0 to 4, the position of the particle changes continuously. The position of the particle changes continuously. And straight line graph. A straight line graph inclined to the time axis shows uniform motion. A straight line graph inclined to the time axis. Inclined to the time axis shows the uniform motion. And we know that if a body is in uniform motion, then its acceleration A is 0. And if the acceleration is 0, then again the force acting on the particle is 0. Since acceleration is 0, because the graph is a straight line and position type graph, a straight line inclined to the time axis means there is a uniform motion, and in uniform motion the acceleration is 0. So no any force or force acting on the particle in this case is also 0. Force acting on the particle is 0 in this case also. And so at t is less than 0, the particle is at rest. So force acts on the particle is 0. For t is greater than 0, greater than 4, the particle is again at rest because its position doesn't change with time. So force acting on the particle is 0. The particle is at rest and force acting on the particle is 0. In third case, between time 0 to 4 seconds, the position is changes continuously, but the straight line graph inclined to the time axis shows that there is a uniform motion, and we know that in uniform motion acceleration is 0. So again the force acting on the particle is 0. Then we have to calculate the impulse at time t equals to 0. This was the first part of the question. Now the second part. The second part of this question. The impulse at t equals to 0 and t equals to 4 seconds. The impulse at t equals to 0 and t equals to 4 seconds. Part B. Impulse at time t equals to 0. So before t equals to 0, the particle is at rest. Before t equals to 0, the particle is at rest. Before time t equals to 0, the particle is at rest. Means its initial velocity before time t equals to 0, its initial velocity is 0. And after t equals to 0, the particle has a constant velocity. After t equals to 0, the particle has constant velocity. Uniform motion and constant velocity. And since it has a constant velocity, then the velocity is found by slope of the graph OA. Velocity V equals to slope of graph OA. And slope is given by tan theta. and tan theta, if angle is theta, tan theta equals to perpendicular upon base. Perpendicular is 3, base is 4. So the velocity is 3 by 4. So after time t equals to 0, means from t equals to 0 to 4 seconds, the velocity is 3 by 4 meter per second. So before time t equals to 0, the velocity initial speed u is 0, and after time t equals to 0, the velocity is 3 by 4 meter per second. And impulse, the formula for impulse is change in momentum. Change in momentum means final momentum minus initial momentum, mv minus mu. M taking common, v minus u. So the value of m is 4, v is 3 by 4, u is 0. So we get 4 into 3 by 4. 4 and 4 cancel, and 3 momentum, mass into velocity, kg meter per second. So at t equals to 0, the impulse act on the body is 3 kg meter per second, and at t equals to 4 seconds. Now we have to find the impulse. Impulse at t equals to 4 seconds. So the same formula will be used. Impulse equals to m v minus u. Now final velocity is 0, because after 4 seconds the body comes to rest, and initial velocity is 3 by 4 and mass is 4. So final velocity 0 minus 3 by 4. So 4 and 4 gets cancelled, and minus 3 kg meter per second. So impulse at time t equals to 4 seconds is minus 3 kg meter per second, and impulse at time t equals to 0 is 3 kg meter per second.